Hello, everyone. I'm Frank, and welcome to episode 27 of Learn How to Sudoku, where we take very easy variant Sudoku puzzles and we break them down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called 18 X's by Blackjack Fitz, and here are the rules. Normal Sudoku rules apply, which means place the digits 1 through 9 once each in every row, column, and box. Digits separated by an X sum to 10. And digits separated by a V sum to 5. All possible X's and V's are given. So in this, for this specific relationship, it's not relationship. This specific rule set is called a negative constraint, which means we know that all x's that are possible and all v's that are possible are given. So if there are ever two digits that add up to 10, they have to have an x separating them. If there are ever two digits that are separated that add up to 5, they have to have a v separating them. And specifically, it has to be a domino. So two cells in that are adjacent to each other. You cannot have, this is not, you cannot, I always wonder if someone ever will create a rule set that has essentially x's in diagonals, right? Or v's in diagonals. But normally in these x's and v's, they're always on edges. So specifically for this all x possible x's and v's, you're looking at two cells that share an edge together. So if you have two cells that ever share an edge together and add up to 10, they will have an x in between them. And if you ever have two cells that share an edge, add up to 5, they will have a v in between them. So for example, we know that if this were a 3, this would have to be a 7 because these two digits add up to 10. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. So, as I said, it says all possible x's and v's are given. That means there are no v's. There are no two cells in this puzzle that have two digits that add up to 5, which are adjacent to each other, right? So nothing can be adding up to 5 for two adjacent digits. We do know that for these digits, you have 8 of them, which must be part of a 2-cell domino that adds up to 10, right? Because all of these add up to 10. Well, what's the only digit that cannot add up with 10 to another unique digit? It has to be 5, right? And also, yeah, all these digits add up to 40, and there's 8 digits adding up to 40. Therefore, the last digit must be 45 minus 40, which means it has to be 5. So this is a 5. 5 can never be next to an x because it can never add up with another cell to add up to 10 because it would have to be 5 and 5, and that breaks normal Sudoku rules. So 5 cannot be here. 5 cannot be here in box 2. And we number these boxes 1, 2, 3, 4, 5, 6, 7, 8, and 9 because that's normal Sudoku convention. It's also normal, it's usual Western reading convention. So in box 2, where is the 5? It cannot be any of these cells. It can't be next to an x. Therefore, it must be one of these two cells. Similarly, in box 8, where is the 5? It cannot be any of these cells, can't be next to an x, so it must be one of these two cells. Let's see. This can't be 5, so one of these three is 5. Oh, it's the same in box 4 and 6, right? You have an X here, an X here, an X here, an X here, which 5 can't be next to, and 5 can't be in the middle row, so 5 has to be one of these two. And similarly for these, cannot be next to an X, and it can't be in the middle row, so it must be one of these two. Okay. Where can the 5 be in box 3? Well, it can't be any of these cells because the 5 in one of these two cells eliminates this. Can't be any of these cells because the 5 in these two cells eliminate that possibility. And it can't be next to an X, and it can't be the given digit. So it can't be any of these, it must be here. So this is a 5. Similarly here, where is the 5 in box 7? It can't be here because of the 5 in these two cells. Can't be here because of the 5 in one of these two cells. And it can't be next to an X, so it must be here. So this is a 5. Therefore, where is the 5 in box 1? It can't be any of these cells. It can't be any of these cells because of this 5 and one of these two being a 5. It cannot be any of these cells because of the pair of cells that could be a 5 here. And it can't be that one, so it must be here. So this is a 5, and similarly, this is a 5, right? Because these two cells see these three cells. This one eliminates 5 from this cell, these two eliminates 5 from that cell, and this 5 eliminates 5 from that cell. So this has to be a 5. Okay. Now, what I like doing, particularly when we have a whole bunch of X's and V's, actually, but since we don't have any V's, what I like doing with X's is coloring them distinctly. Specifically the pairs of cells, right? Because you have two digits which you know add up to 10. So any corresponding digit that is the same set would have to be with the next digit that's also corresponding to it. So we're going to color these. This is green. We're going to make this red, this blue, and this orange. So these are the pair of these. This is the blue pair. This is the red pair. This is orange. This is green. Now, anytime you have a pair in that sees any of, so like for example in row 4, you see two that are basically going to be, that cannot be green, right? And it can't be orange because if you have two digits seeing this one, if one was orange, that means it would be that one, but then the other orange would have to be there too, which would eliminate any possibilities for that being orange. Therefore, this has to specifically be blue or red, and this has to specifically be blue or red. Similarly for this has to be green or orange, and these are green or orange. Similarly for this can't be blue or orange, so it has to be green or red. So this is green or red, and this is green or red. And this has to be blue or orange, and this is blue or orange. Okay. We know then the last remaining digit, aside from the 5, in we actually don't have that much information there. We do know, okay, so one thing we do know is the last remaining digit in row 6, row 4, column 4 and column 6 must match essentially the obviously the digit that does not have 2 of that pair in that row column, a row or column, right? So in row 4, we have one of these is a blue pair, one of these is a red pair. We also have a green pair already. Well, what's the last digit that's not colored? It has to be another orange. But if this were orange, it would basically have to be with this orange, and therefore there would have to be an X in between them, right? So this can never be the orange. Where is the orange then? The last remaining orange in row 4. It has to be here. Because again, if this were the orange and this were 5, this would have to have an X in between them. And that's how then you use negative constraints, right? Because negative constraints tells you that all possible X's and V's are given. So if you didn't have the negative constraint, this could have actually been the other orange. But since we do have the negative constraint, this can never be the other orange. So therefore, this must be the orange, which means it cannot be 5, which means this is a 5. This can't be 5 anymore. This has to be 5. And it's similar across, because this is symmetrical. It's rotationally symmetrical around 90 degrees around the central cell, right? This is exactly the same here. It's exactly the same here, right? So if the remaining digit in column 6 has to be the last blue, right? And it cannot be here because then there would be an X in between these two cells. So therefore, this must be the blue, which means this cannot be 5. This has to be 5. This has to be 5. And this can't be 5. So this is the last orange. This is the last blue. This is the last red. Aha. And this is the last green. So because we know one of the red is here, this can no longer be both reds, right? Because obviously one of them is here. So therefore you cannot have 2 reds here. So therefore this is blue, which means this can't be blue. This has to be red. Similarly, this is orange, so this can't be 2 oranges here, so this must be 2 greens, which means this can't be greens. Similarly here, this is a green, so therefore this can't be 2 greens, which makes that a red, so therefore this can't be red. And again, this can't be blue because we have a blue already in the box, so this can't be orange then. Well, we know this is a green. This is an orange. What can this not be? It cannot be green, and this cannot be green. Okay. What else do we know? Digits separated by X sum to 10. All digits, okay. The blue and the orange, actually, that's interesting. Yes. Where are the blue and orange in box 4? The orange cannot be here because if this were orange, this would be, this would have to have an X in between them. What if the orange were here? If the orange were here, both of these remaining cells must be blue. Well, if they're both blue, then that means there would have to be an X in between those if this was orange. And that's not showing there that way too. So this is how you use negative constraints again. Therefore, the orange cannot be here because there would be an X here. Cannot be here because then these would both be blue and there would have to be an X in between those. Therefore, where's the only place that orange could be? It has to be here, which means this is blue and this is blue. And you can follow that similar logic everywhere else in the boxes 2, 6, and 8. Therefore, this cannot be blue, this cannot be blue, this must be the blue, which means the remaining one is red. So this is red and this is red. This cannot be red and this can't be red, so therefore this must be red, which separates the greens. This has to be a green separating the oranges. Therefore, we know that this can never be green or orange, and this can never be green or orange. Therefore, it's either blue or red. Well, if this were red, if these two were both red, you would have a red with next to each other, and that would have to also have an X in between them. Because there's only, the only two digits that add up to 10. But so therefore this can never be red. Therefore this must be blue. This has to be red. Blue can never be here. That's fine. And this, similarly, this has to be green or orange, but it can't be next to an orange, because if these were both orange, this would have to have an X in between them. So therefore this has to be green. This has to be orange. What are the remaining non-filled colors? It must be blue and red, but this can't be blue because, again, of the negative constraint. So therefore, this, if this were blue, this would have to have an X in between them. Therefore, this is a red. This is a blue. And we can similarly figure out what these are. It must have a green and an orange in the last remaining cells. Well, this can't be green because then this would be an X in between them. Therefore, this is an orange, and this has to be green. Let's see. Therefore, this has to be, cannot be red, because the red already has two cells in box 7. Cannot be orange, because we already have one cell in box 7. And cannot be green, because we have two cells in column 2. Therefore, it must be blue also. So these are both blue. What's the last remaining cell that's not a 5 in column 2? It has to be an orange. So this is orange. What's the last remaining cell? Well, actually, we have a 4, so we're not sure. So these two cells cannot be both the same color. Because if they were, there would be an X in between them, right? This is why I like coloring the two dominoes that add up to 10, because we know exactly which dominoes must add up to 10. Therefore, this cannot be both greens. One of them then has to be green, and one is orange, which means the digit in the remaining cell must be a green. So this must be a green. So all the greens are 4s and 6s. And this must have a green or orange. We're not sure which. Well, this has to be a 6. This has to be a 6 because it can be only 4 and 6s in the greens. And therefore, it can't be 4. So this must be 4. This can't be 4. So this is 6, which makes that a 4. Again, these are 4s and 6s. And this is a 4 and a 6. And this is a 4 or 6. This is 4, 6. This is 4, 6, 4, 6. We have a 4, 6 here. So one of these is green, one of these is orange. What are the two remaining colors here? It has to be red and blue, right? We have one green, one orange here, which makes 2 greens and 2 oranges in column 3. So the green and orange are no longer possible in column 3. Therefore, we have blue and red. So this has to be specifically blue and red, but we're not sure which one is which. This is green or orange. What's the last remaining cell in box 1? It has to be an orange and it has to be a red, because one of these is red and one of these is blue, which means we have 2 blues in box 1. We have both greens in box 1. Now, if this were an orange, the problem is, again, from a negative constraint, these would have to have an X in between them. So this cannot be the orange. This has to be the orange, which means this must be the red. So the reds must be 3 and 7. So this is 3 and 7, this is 3 and 7, this is 3 and 7. 3 and 7, 3 and 7, 3 and 7, and this can't be 7, therefore this is 3, which makes this a 7, which makes this 3, which makes that a 7. These are 3 and 7. Okay, so what does that leave then? Well, orange cannot be 3 or 7, and it cannot be 4 and 6, and without the 1, it cannot be 1 and 9. So the oranges have to all be 2 and 8. So this is 2 and 8, which means the blues all have to be 1 and 9. And therefore this is a blue. We're going to remove that because it's multiple possibilities. Therefore, you cannot have the blue be in box 3 in these two cells. You also cannot have the orange because there's 2 oranges already in the cell. And you cannot have 2 reds because we already have 1 red in the cell. So this must be green, the green pair. And we know there are no 2 digits in the entire puzzle that adds up to 5. So if this were 4, this would have to have a V in between them. So this cannot be 4. This has to be a 6, which makes this a 4. That 6 makes this a 4, which makes that a 6. We know one of these is blue and one of these is red. So this is a blue-red pair. What's the last remaining cell in column 8? It has to be a red. So this is a red. What are the last remaining cells in... This can't be 1, so this is a 9, which makes this a 1, which makes that a 9, which makes that a 1, and that's just normal Sudoku. We have an orange and a red left here. And this can't be red because then this would have to have an X in between them. Therefore, this is not blue, this is an orange, and this must be a red. What about these two? It has to be orange and green. So this is orange and green. Well, this orange is next to both reds. And one of those reds has to have a 3. So if this were 2, there would have to be a V in one of these boxes, but in one of these edges, but there isn't. So this can never be a 2, right? Because it's next to both reds, which would be one of them's 3 and one of them's 7. And there's no V in between, therefore this must be an 8, which makes this a 2, which makes this an 8, which makes this a 2, and makes that an 8. This can no longer be 3 then, because that would add up to 5, and as I said, we know in the puzzle, the entire puzzle, there is no digit that adds up to 5 because there's no V's, and it says all possible V's are given. So this must be a 7, which makes this a 3, which makes that a 7. That's 3 in the corner. We celebrate. This can't be 7, so this is a 3, which makes that a 7. Okay. Let's see. This cell sees both of the orange cells. Therefore, it must be next to a 2. So if the 3 were here, and we know the 3 has to be one of these 2 cells, if the 3 were here, it would guarantee that it would be next to a 2. because one of the 2's has to be in one of these orange cells. Therefore, there would be a V in one of the edges surrounding this cell, but there isn't. So this can't be a 3, which means this has to be the 3 and is the red, so it can't be blue. This can't be the corresponding red. We have 2 reds now in row 1, which means the rest of the row cannot be red. So this can't be red, which makes that blue. This can't be blue, so this must be red. Therefore, this must be a 9. This can't be a 3, so this is a 7, which makes that a 3. This 7 means this can't be 7, so this is a 3. This is a 1 or a 9, but it can't be 1 because, again, these 2 digits would have to add up to 5, and therefore there would be a V signifying that that's the case. So this can't be 1, which makes this a 9, which makes that 1. This 9 means that has to be 1, which makes that a 9. This can't be 9, so this is a 1, which makes that a 9. This can't be 1, so this is 9, which makes that 1. This can't be 2, because it would be next to a 3. And again, we said you can't have 2 digits adding up to 5 in the puzzle anywhere. So therefore, this is 8 adjacent digits. This is 8, this is 2, this is 8, this is 2, this is 8. And that's just all normal Sudoku. This can't be a 1, similarly, because that would add up to 5. Therefore, this is 9, this is 1, which makes that a 9 and that a 1. This has to be 2 or 6. This can't be 8, so that's 2, which makes that 8, which makes that 2, which makes that 8. This can't be 8, so this must be 2, which makes that 8. This can't be 7, so this is 3, which makes that 7. Now, if this were the orange, it would have to be a 2. And therefore, it'd be next to a 3. But again, we can't have 2 adjacent digits adding up to 5. Therefore, this cannot be the orange. It has to be the green, which means this can't be green. This has to be orange. So this is the 2 here. This can't be orange because we have 2 oranges in that row. This can't be green then. So this is orange. So therefore, this is the 2. And this has to be 6. And again, we have the negative constraint here. This cannot add up to 5, so this cannot be a 4. So this makes that a 6, which makes that a 4. Therefore, that's a 6. This is a 4. This can't be 6. So, oh, sorry, this can't be 4 because of that 4. So this is 6, which makes that 4, which makes that 6. And therefore, this is a 4. This can't be 7 because of this 7. So this is a 3. And that's a 7. Huzzah! We solved it. Yeah, in this puzzle, the most important rule probably was the negative constraint, constraining all the possible x's and v's. And I like coloring these pairs instead of coloring individual cells because it gives you immediately recognition of essentially where things can and cannot be, particularly with the negative constraint, right? Anyways, I hope you enjoyed learning how to Sudoku, and I'll see you next time on Frank Puzzles. Take care.